Hello friends, welcome to our channel Mechanical Motivator. In this video, we will be seeing problems on gyroscopic couple in ships. So in this tabular column, we can easily get information regarding whether the ship is depending upon the pitching, that whether the bow is raised or stern is depressed. Depending upon that, we can have 8 different cases. Detailed explanation of the concept has been delivered in the previous video, so those who haven't watched means kindly check the playlist and understand the concept of gyroscopic couple and ship and then see the problems. So we should have this tabular column in order to determine the effect of the pitching, and the second tabular column will be determining whether the ship turns to port side or starboard side. So both this concept has been clearly explained in the previous video. Now we'll go directly to the problem. A ship is propelled, actually the line has been, a ship propelled by a turbine rotor which has a mass of 5 tons. So mass is equal to 5 tons. So 1 ton is 1000 kg, so 5000 kg. So and speed of 2100 rpm. So n is equal to 2100 rpm. So just convert the speed into angular velocity. Angular velocity formula 2 pi n by 6c to 2 pi 2100 divided by 60. You will be getting an answer 220 radian per second. Next, the rotor has a radius of gyration as 0.5 meter. So k means radius of rotation. So k means radius of rotation. So that value we can have 0.5 meter. Rotates in a clockwise direction. So we need to know whether the rotor or turbine rotates in which direction. So here we can see it's rotating in a clockwise direction. So just have a mark of it. And when viewed from the stern, so viewpoint is stern and rotation is clockwise. Find the gyroscopic effect in following condition. So first condition is the ship sails at a speed of 30 km per hour and steers to the left. So the ship is turning left side in a curve having 60 meter radius. So directly we go to first condition, the ship steers to left side. So the ship is turning towards the left. It's going with a velocity of 30 km per hour. 30 km per hour, convert into meter per second. So just multiply into 1000 divided by 3600. So for kilometer you are multiplying by 1000, and for hour it's 60 into 60, so 3600. So finally you will be getting a value of 8.33 meter per second. It has taking a left turn right, so have a curve radius as 60 meter. So r is equal to 60 meter. We know that the angular velocity of precision, so omega p formula is velocity divided by radius of curve. So v divided by r. So velocity is in terms of meter per second and radius is 60 meter. So just get the value of in terms of radian per second. Next is we need to determine the gyroscopic couple, right? For that we need the value of mass moment of inertia. So mass moment of inertia of the rotor is mk square. So mass we know 5000 kg and radius of gyration is 0.5. So just get the value in terms of kg meter square. So gyroscopic couple formula is C is the gyroscopic couple, I omega and omega p. This omega we already found in the given data. Omega we got the value, and omega p, that is angular velocity of precision, we got. So just substitute all the values and you will be finally getting value in terms of Newton meter. If you want, you can also convert to kilo Newton meter. For writing the effect, we just need to know, that is whether which direction the rotor is rotating and from where we are seeing, and the ship turns left or right. So when the rotor rotates in a clockwise direction, when viewed from the stern, the ship steers to left. So just go to the tabular column. You're looking from the stern and the rotor is rotating. You're looking from the stern and rotor is rotating in a clockwise direction and ship is taking a left turn. So bow is raised and stern is depressed. So this is the effect. The effect of reactive gyroscopic couple is to raise the bow and lower the stern. Second condition, the ship pitches 6 degree above and 6 degree below the horizontal position. So pitching degree they have given. The bow is descending. So bow is descending means bow is getting downwards with its maximum velocity. The motion due to pitching is simple harmonic and periodic time is 20 seconds. So time period they have given. So second condition, the ship pitches with bow descending means bow getting downwards. So pitching angle, that phase angle they have given 6 degree. So 6 degree just convert into radian per second. So into pi by 180. So you'll be getting in terms of radian per second. Time period they have given us 20 seconds. We know that angular velocity in simple harmonic motion, that is, this is the formula for angular velocity in simple harmonic motion. So we can write as omega 1, because already we have the notation omega. So in order to, we should not get confused, so we are using a different notation. Omega 1 is equal to 2 pi by tp. Time period we know, and we can write the value in terms of radian per second. Maximum angular velocity of precision is omega p max is 5 into omega 1. So 5 angle we got into omega 1. So we will be getting an answer in terms of radian per second. Maximum gyroscopic couple is same formula, just write maximum on maximum gyroscopic couple, and here also we'll be having maximum angular velocity of precision. So just substitute all the values and we will be getting in terms of Newton meter. Now we're going to write the effect. That is, the ship is pitching with bow descending. That is, the bow descending means bow getting downwards. So just go back to the tableau column. So we are looking at we were looking from the stern point, right? So looking from the stern point, and the direction of rotation is clockwise, and now it's getting downwards. So downwards means the ship turns towards the port side. Second case. So just see the effect. Therefore, the effect of its maximum gyroscopic couple is turn the ship towards the port side. So port side is the answer. Third condition is the ship rolls, and at a certain instant it has an angular velocity of 0.03 radian per second. They are given the value of angular velocity and clockwise when viewed from stern. So these are the condition. Now we need to determine also the maximum angular acceleration during pitching, and explain how the direction of motion due to gyroscopic effect is to be determined in each case. Actually, we have determined the effect for all the cases. In this case, we need to determine the maximum angular acceleration during pitching. The third case. So now the third case, they are saying the ship is rolling, right? So ship rolls. So third case is ship is rolls. Actually, this condition is not at all possible. Ship can't roll, right? Since ship rolls at an angular velocity, they have given 0.03 radian per second. Therefore, angular velocity of precision, that is when ship rolls, is omega p. They have given the value directly. Now determine the gyroscopic couple. We know the value of omega. Omega p they have given in the given data, and you can determine the value in terms of Newton meter. But in case of rolling of the ship, in what happens is the axis of precision will be parallel to the axis of spin. So in this case, the ship can't roll at all. Because axis of spin should be perpendicular to the axis of precision. So as they given, if the ship rolls means, then these two axes should be parallel. Therefore, there won't be any effect of gyroscopic couple. So this is the answer, and this is the reason for that, since they are parallel. And maximum angular acceleration during pitching. So this is the formula. Maximum angular acceleration can be represented as alpha max. So 5 into omega 1. So omega 1 we know. Omega 1 we got already. So just substitute the value, and 5 value we already know. Actually, from previous case, the 5 value we have determined, right? So just substitute that, and you'll be getting radian per second square. So just make the note of the unit alone. Radian per second square. In second problem, the turbine. The turbine rotor of a ship has a mass 3500 kg. So mass is equal to 3500 kg. It has a radius of rotation 0.45 meter. K value 0.45 meter. A speed of 3000 rpm. So n is equal to 3000 rpm, and just convert into omega. So omega is 2 pi n by 60. When looking from this stern, clockwise direction, and looking from this stern, just mark a note of it. Determine the gyroscopic couple and its effect upon the ship. They have given two cases. So we'll see one by one. So main thing is we need to know from where we are seeing and from in what direction the rotor rotates. These two conditions is very, very important. So first case is the ship is steering towards the left. Now ship is turning left side on a curve of 100 meter radius. So R is 100 meter and speed is 36 kilometer per hour. So first case we know when the ship steers to left side, R value they have given, and velocity 36 kilometer per hour. So automatically 36 into 1000 divided by 3600, you will be getting a value of 10 meter per second. Mass moment of inertia, I value mk squared, m value you know, and k value you know, just calculate as it is. Angular velocity of precision. So angular velocity of precision, we know the formula omega p is equal to v by r. So velocity we know and radius we know. We can easily calculate. Finally, gyroscopic couple formula is I omega p. I value we know, omega value we know, omega p also we know. So just substitute all the values and calculate in terms of Newton meter. If you want, you can also keep in terms of kilonewton meter. Now the rotor rotates clockwise direction when looking from stern and ship turns left turn. So go back to the tableau column. So stern clockwise direction, ship turns left. So bow rise and stern depressed. So here we can so the effect of reactive gyroscopic couple, we actually always need to consider only the reactive gyroscopic couple. Active gyroscopic couple is not considered. Reactive gyroscopic couple is raise the bow and lower the stern. That's it. So second case is when the ship is pitching in a simple harmonic motion, the bow falling means bow downwards with its maximum velocity. The period of pitching, time period they have given 40 seconds. The total angular displacement between the two extreme position of pitching is 12 degree. That is, pitching means lowering and downwards and upwards. The total angle they have given as 12 degrees. So time period I have given. Since the total angle for extreme position is 12 degree, so 2 phi is equal to 12 degree. So automatically phi will be 6 degree and just convert into radian per second. So pi by 180 and you will be having a value. Angular velocity of simple harmonic motion, we know the formula omega 1 is equal to 2 pi by tp we previously saw. So just substitute the value and you will be getting the value for omega 1. And maximum angular velocity of precision is omega p is phi into omega 1. So phi value you know calculated, omega 1 just now we calculated, substitute the value and get the value in terms of radian per second. Gyroscopic couple, C is equal to I omega p, and I value omega value omega p just substitute and you will be getting in terms of Newton meter and you can convert to kilonewton meter. In this case he is not asking the effect. If he is specifically asking means we can go for it. In case if they are not asking means no need to worry about it. In next problem, a turbine rotor of a ship has a mass of 2000 kg and rotates at a speed of 3000 rpm. So mass is 2000 kg and speed is 3000 rpm and convert into omega. So keep in terms of radian per second. Clockwise when looking from the stern. So same condition is clockwise looking from the stern and radius of gyration is k value they are given. Determine the gyroscopic couple and its effect on the ship. When the ship is steering to the right side, now it's right side and having a radius 100 meter and having a speed of 16.1 knots. So 16.1 knots is they have given the data also. 1 knot is equal to 1855 meter per hour. So use those data for conversion. So V is equal to 16.1 knots. So 16.1 into 8555. It's in terms of meter already given. So in terms of hour means divided by 60 into 60. So 3600. So convert into meter per second. You are just multiplying the given data. That is 1 knot is 1855 meter per hour. So just multiply meter, no need to convert. For hour we going to convert like 16 to 60. So 3600. So calculate in terms of meter per second. Calculate also the torque and its effect when the ship is pitching in simple harmonic motion and bow is falling with a maximum velocity. Period of time period they have given and total angular, the extreme position angle they have given 12 degree. And also we need to find the maximum angular acceleration during pitching motion. So alpha max we need to determine. So as we know, so gyroscopic couple is first we calculate the gyroscopic couple. That is First, we calculate the gyroscopic couple. So for that, we need a mass moment of inertia, right? So I is equal to mk square. M value, k value, we know. So just calculate. Angular velocity of precision, we know. V by r. So velocity and r value, we know. So just use those values. And gyroscopic couple formula is this. C is equal to I omega p. So substitute all the given data and you'll be getting in terms of Newton meter and kilonewton meter. So when the rotor rotates in clockwise and looking from the stern, ship turns right means. So go back to the tabular column. So stern clockwise right direction. So bow is depressed and stern is raised. The effect of reactive gyroscopic couple is to raise the stern and lower the bow, as we saw from the tabular column. So next is we need to determine torque. So torque during pitching, that is time period they have given. Time period they have given 50 seconds and 2 phi is 12 degrees. So phi is 6 degree. Convert in terms of radian Next is we need to determine the angular velocity of simple harmonic motion omega 1 2 pi by dp. Substitute the values and get in terms of radian per second. And maximum angular velocity of precision omega p max is 5 into omega 1. So substitute all the values and get the in terms of radian per second. The torque is nothing but the maximum gyroscopic couple. So don't get confused. If they are asking torque means it is the maximum gyroscopic couple. So maximum gyroscope couple is I omega omega p. So substitute all the values and you can easily determine in terms of Newton meter. So from the tableau column. So when pitching is downwards, right? So pitching is downwards and the ship turns. See, listen. Go to the tableau column. Yeah, it's looking from the stern and clockwise and it's downwards. So automatically ship turns towards the port side. So the effect of the reactive gyroscopic couple is to turn the ship towards the port side. And at last they are asking the maximum acceleration during pitching. So alpha max is the value formula. So alpha max is the notation. So formula is 5 into omega 1 whole square. So just substitute all the values and you'll be getting. So these are the few basic problems from the gyroscopic couple and ships. And the main thing is we need to understand the concept behind this effect. So that's all about the topic. In case if you are having doubt, means in university maximum they will be asking problems from ship and four-wheelers. And in case if you are having any doubt in this problem, just type in the comment section and I will be clarifying your doubts. Please do subscribe to my channel Mechanical Motivator and press the bell icon. Then only you will be getting all the videos which I upload. Thanks for watching this video. Have a great day.